Dear students, good morning. From last two chapters, you could learn about motion and its related laws, that is Newton's laws of motion. Today I am going to introduce new chapter, gravitation. This chapter helps you to explore very important concepts such as gravitation and law of gravitation. Other important discussing points from these chapters are: first, motion of objects under the action of gravity; second, factors related to variation of weight of a body; and third, conditions for objects to float in liquids. Today's the discussing topics are: first, introduction to gravitational force and gravitation; second, universal law of gravitation; and third, derivation of universal gravitational law. Now I bring you to very important part of this chapter. What are the gravitational force and the gravitation? This chapter will help you to understand the importance of studying the gravitational force and the gravitation. We know that the satellites move around the planets. Example, the moon, which is a natural satellite of the earth, moves around it. We always observe that an object thrown upwards reaches a certain height and then falls towards the ground or the earth. We know that all the planets go around the sun. The moon goes around the earth. In all these cases, there must be some force acting on the objects, the planets, and on the moon. Sir Isaac Newton could grasp that the same force is responsible for all of this. This force is called the gravitational force. Do you know there is an interesting story behind the discovery of gravitational law? One day, Newton was sitting under an apple tree. An apple fell on his head. He suddenly thought of his reason. And finally, he found his cause and he named the connected law of this motion as universal law of gravitation. Newton thought that if the earth can attract an apple, why not moon or other celestial bodies? If moon is attracted by earth, why it does not fall towards it? Is the force the same in both cases? Why earth is not moving towards apples? These are the some questions which came to him when he saw an apple falling from a tree. Just before, I had used the term celestial body. What is meant by a celestial body? The celestial bodies are the natural bodies which are located outside the Earth's atmosphere. This natural body may be located anywhere in universe. And you have to come to know about the terrestrial bodies. What are the terrestrial bodies? These are the natural bodies which are located on the surface of the earth. Let me proceed over. Newton conjectured that the nature of the force is same whether it is moon or earth, and earth attracts all bodies towards itself. Here you have got one term, conjecture. What is its meaning? Conjecture is making an opinion or drawing a conclusion which is on basis of incomplete information. Newton argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. But it is not really seen that the moon is falling towards the earth. Now, as force is there, then why there is no acceleration? Well, there is acceleration called centripetal acceleration, and the force which causes this acceleration is termed as centripetal force, which always acts towards the center. Let us do an activity to understand the motion of the moon and study the nature of centripetal force and centripetal acceleration. This activity, what is going to do now is the activity which had done earlier to study the uniform circular motion in chapter 8 motion. Can you remember about it? Take a piece of thread, tie a small stone at one end, hold the other end of the thread and weld as shown in figure. Note the motion of the stone, release the thread, again note the direction of motion of the stone. What can you observe and understand from this activity? Let me discuss on it. Here, the velocity of the stone at any instant of time is along the tangent to the circle at that instant. Before the thread is released, the stone moves in a curved path with a certain speed and changes its direction at every point. You learn that change in direction of motion involves change in velocity, which produces acceleration or centripetal acceleration. The force that causes this acceleration and keeps the body moving along the circular path is called centripetal force, which directs towards the center of circular path. So it is called center-seeking force. Then acceleration produced by this force also have the same direction. You observe that the stone flies off tangentially when the thread releases. This is because when the thread releases, centripetal force whirling the stone vanishes. Therefore, on account of inertia, the stone flies off tangentially. Here, you understood that an object moving in a circular path experiences centripetal force. It changes the direction of this object at every instant of time. These 2 points can explain the movement of planets around the sun. The motion of the moon around the earth is due to centripetal force. This centripetal force is provided by the force of attraction of the earth. The moon revolves around the earth due to the centripetal force, which is the force of gravity of the earth. If the force of attraction between the earth and the moon ceases, then the moon will continue to travel in a straight line path tangential to its orbit around the earth. From earlier session, you have realized that the apple's fall on Newton's head was due to the force of attraction of the earth towards itself, or the gravitational force. This clarity was given by him. You know that the earth is also attracted towards the apple by the same amount of force, which is in accordance with Newton's third law of motion, but it cannot see the earth moving towards the apple. What is its reason? The reason is acceleration produced in the earth due to this force is inversely proportional to its mass, which is known by Newton's second law of motion. And mass of the earth is very large in comparison to this apple. So, Earth's acceleration is negligible as compared to the apple's acceleration. Therefore, it cannot observe the earth moving towards the apple. Next part, you are going to study about universal gravitational law. What is Newton's law of gravitation or universal gravitational law? According to universal law of gravitation, every object in the universe attracts every other object with a force directed along the line of centers for the two objects that is proportional to the product of their masses and inversely proportional to the square of the separation between the two objects. Here, the force of attraction between two objects is directly proportional to the product of their masses and inversely proportional to square of distance separation between the two objects. The force is along the line joining the centers of the two objects. Let us consider two objects A and B of masses m1 and m2 lie at a distance r from each other as shown in figure. Let the force of attraction between two objects be F. According to the universal law of gravitation, the force between two objects is directly proportional to the product of their masses, and this force is inversely proportional to the square of the distance between them. Here we are going to derive universal law of gravitation. The two relation which we have got from the statement of law of universal gravitation can be expressed mathematically. First one, F is directly proportional to m1, m2. And second one as F is inversely proportional to r square, or F is directly proportional to 1 by r square. By combining these two expressions 1 and 2, we get F is directly proportional to m1 m2 divided by r square. Then F is equal to g into m1 m2 divided by r square, where g is the proportionality constant, or it is the universal gravitational constant. We have the expression F is equal to G m1 m2 divided by r square. This is the equation number 1. Then F r square is equal to G m1 m2. So G is equal to F r square divided by m1 m2. This is the equation number 2. The SI unit of G can be obtained by substituting the units of force, distance and mass in the expression 2, which is Newton meter square per kilogram square. You know that the SI units of force, distance and mass are Newton, meter and kilogram respectively. So the value of G is equal to 6.673 into 10 the power of minus 11 Newton meter square per kilogram square. Now you are going to study how to answer the two questions, which are first one, why is gravitational law called universal gravitational law? It is called so because it is applicable on all bodies having mass, and the bodies will be governed by the same law, that is Newton's law of gravitation. These bodies may be celestial or terrestrial bodies. Thus, as it is applicable universally, it is called as universal law. And second question is, why is Newton's gravitational law called inverse square law? Because the gravitational force between two bodies is inversely proportional to the square of the distance between them. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.